All right, we're going to continue where we left off just a second ago. This was our 2.2 limit video. This video will be, I'm going to keep it on the same thing so that it's just one document when I upload it. 2.2 limit, we'll call this 2.2b, limit of a function. And this is going to be where y does not exist. Not y or y, where L. Let's rewrite down the definition of the function real quick. Limit as x approaches a of f of x equals L. So this video is going to be on if L does not exist or is infinite. Okay. All right. So we had up above, what color did I use up above? I used blue for g of x and that bay or not bay, I don't even know what color, peach color. I used blue for f of g of x. G of x was absolute value of x plus 1 over x plus 1. And our graph showed this. To the left of -1, it was equal to -1. And to the right of -1, it equals +1. And we'll do the algebra for this in the next section. We're just talking about the idea of limits here. So if I look at the limit as x approaches -1 from the left here on g of x, I'm looking at like, what is my y value as I get closer and closer and closer? And here it's -1, the y value here is -1, it's -1 here. The limit from the left is -1. If I do it from the right and I'm approaching that value, I'm looking, what is the y value here? It's +1 the whole way. So we're going to say limit as x approaches -1 from the right of g of x equals +1. Since these two are not equal, these are not equal. And we said the limit existed and equaled L if those two were equal. So when they're not equal, we say the limit as x approaches -1 in general of g of x is DNE, does not exist. If someone needs more information, I don't want to use yellow. Student in the class doesn't like yellow. If more information is needed, use the one-sided limits, which are right up there. In this case, the one-sided limits, they're just more descriptive. They let us know why it doesn't exist. Then we have the concept of infinite limits. So infinite limits. This is different than limits at infinity. They have similar words, they use the same words, but we'll do limits at infinity later on. Infinite limits, was like my h of x. H of x up above was 1 over x plus 1 squared like that. And I showed a graph like this. At -1, we had a vertical asymptote. And the graph did something like this. This is x and this is y. And now if we look at the limit as we approach left and right here, limit as x approaches -1 from the left on my h of x right here. This is like what's happening. It's getting higher and higher and higher and higher. And the closer I get, it just keeps going up. It keeps going up without bound. This is math speak right here. It keeps increasing. And they say it like this, without bound. Bound is like a boundary. There's no boundary to how far we can increase. The sky's the limit kind of thing. When in this situation, it's going up, up, up to positive. So we're going to say positive infinity. The same thing actually happens if we approach it from the right. Okay. Infinity, positive infinity or negative infinity, is not really a number. It's an idea, concept. So the limit of x approaching -1 here of h of x technically does not exist, DNE. But we don't say that. That's not helpful information. We tend to say for this, the limit as x approaches -1 of h of x equals positive infinity. Okay. If we had something like f of x equals -1 over x plus 1 squared, then when we do this, this is all going to have negative values. And we're going to say the limit here is negative infinity because the negative sign affects it. I'll give you some rules in general when we have this type of thing in just a second. I do want to show something that happens differently though. If we look at f of x equals 1 over x, the graph of 1 over x, actually the x-axis and the y-axis are asymptotes for f of x equals 1 over x. X and y are both asymptotes. And it does some stuff like this. It approaches the axes like that from the right of 0, and it approaches the axes like this from the left of 0, but x cannot equal 0 because it's on the bottom of the fraction. Okay? So if I do the limit as x approaches 0 from the left of 1 over x, this is what's going on pictorially as I do this. I'm going this way, I'm going this way, I'm going this way, I'm going this way. As I get closer to this is x equals 0, is the vertical line right here. This is approaching negative infinity. So we're going to put negative infinity there. If I look at it as it's approaching it from the right, where as we get closer to x equals 0, this value keeps going up, 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 and up. It's going to positive infinity. Since those are not equal, one's positive, one's negative, this one we have to very specifically say the limit as x approaches 0 of 1 over x, DNE. It does not exist. You with me so far? I hope so. I hope you're pausing and taking notes as you need to. We do have, like, this is all in the category of f of x equals 1 over x minus a to the nth power. So if n is a positive even integer, like n equals 2, 4, 6, 8, etc., the limit as x approaches a of 1 over x minus a to the nth power is going to equal positive infinity every time. If n is a positive odd integer, like n equals 1, 3, 5, 7, 9, then the limit as x approaches a from the left of f of x is negative infinity. Limit as x approaches a from the right is positive infinity. So limit as x approaches a in general is DNE. And I'm going to stop this there.